This video is going to be over factor trees, which, if you don't know what a factor tree is, this is going to give the idea of a factor tree and how to do it. So we have 9 here, which is a pretty simple number to factor. And all you do for a factor tree is you try to break it down as much as you can. So you're trying to get this to the smallest number of numbers. You're trying to get this to the smallest numbers you can that multiply to this. So this is going to be a simple one, because if you look at 9, you should be able to see that 3 and 3 equal 9. So 1, you have a 3, and then over here, we have a 3. These multiply together. 3 times 3 is 9. 3 cannot be broken down, because if you try to break it down, let's just try this. We get 1, and we get 3. I mean, we just kept the same number. So we can't break 3 down anymore. So that's going to stay. This is the same 3. You can't break it down anymore. So 9 broken down is 3 times 3. There's a similar number would be 4, which we'll just show 4 really quick. 4 can be broken down into 2, and it can be broken down into 2. If you try to break 2 down, you're going to get 1 times 2. It it's already broken down. We just have another 2. There's no point in that. So now, if we're going to try a larger number here. We're going to do 16. So there's multiple ways to do this. And I'll go over the different ways. But the first one, let's say that you look at this and like you trying to find two numbers. And I'll give you a second to see if you can think of this. You can pause it if you want. But um, you can either try to figure it out or just figure out the first two numbers. I will be doing this one again to show all the combinations. So you've had some time. I'm going to start with 2 and 8. I'm so bad at making 8s. There we go. So we have a 2 and 8 here. The 2, as we know from over here, can't be broken down, but the 8 can. So if we look here, we can make this as 2 and 4. The 2 can't be broken down, but the 4 can. And we just actually did the 4 over here, 2 and 2. So the smallest numbers that you can get is 2 times 2 times 2 times 2. That's the first way. That's the first way if you were doing 2 times 8. But there's a different way to do this. I'm going to move over. I broke everything. We're going to move over a little bit and write out 16 again, because some of you might have seen 4 times 4 instead. Which we already have 4 here, but let's just do it again really quick. We're going to get 2 and I'm going to get 2 and 2. We're going to get 2 and 2. We got the same answer. 2, 2, 2 and 2. Just this one was more even. And this one over here, we branched off with the 8 to the 2 and the 4 and the 4 to the 2 and the 2. So that was really the only difference between this. We can do another big one. We can do 75. I'll let you see if you can think of one really quick. I'll give you like 10 seconds. So look at this, draw it out. We got 5 and 15. 5 times 15 is equal to 75. 5, we haven't done this, so let's test it. Uh, we can think of 1 and 5. We kept the 5, so this can't be broken down anymore. So it's going to stay a 5. 15 though. Let's say, let's say 3 and 5. Well, 3, did we do that one yet? We did. 3 can't be broken down. Just turns into 1 and 3. We just did 5. So our answer would be 5 times 3 times 5. I'm trying to see if there's another way to do this. I'm not certain if there is. I'm trying to look at it. I don't know if there's another number you could pull out here. There is one. Some of you might have seen this instead, but we'll do it really quick. So you can pull out a 3 and a 25. 25 times 3 is 75. So we already have our 3. 5 times 5 is 25. Again, both ways are correct. And this time they're actually even. It's just you can have both of your 5s paired together here, or you can have your 3. And your 3 over here, or you can have a 5, a 3, and a 5. It doesn't matter what way you do it. It just matters that you eventually get there. So it doesn't matter how many steps it takes, what steps you take, as long as you get here in the end, you will be fine. So this is a general way to do it. All you're doing is, as in the previous video, you're trying to get the factors of numbers by factor pairs, which if you don't know what factor pairs are, you can look at the previous video, which I should have linked up in the corner, and I will put it in the description as well. But this is an introduction to factor trees. It's just a way to visually organize the way that you're doing it. It lets you kind of see like, okay, I can see how I got a 3 out here, and I can see how there's a 25 left. And you don't have to be in your head like, okay, so I got a 3 and a 25. The 25 has to break down to the 5 and 5. And what was the other number? You don't have to think about that. You can just write it down and you can keep breaking it apart until you can't anymore. It also lets you test, like, hey, is 5 good? No, five is that 5's perfect. We don't need to break it down anymore. We are good.